Okay. Hello, everyone. Buongiorno. Thank you for joining the session with me about how to save money on your SQL Server hardware. The lessons you're about to see in this session to on-premise as well as in the cloud environment, and I hope you learn something new. It's very important lessons. So let's get to it. First, a few words about me. My name is Eitan Blumin. You can also pronounce it as Ethan. I'm a senior SQL Server consultant at Madeira Data Solutions and also a DBA team leader. We're situated in Microsoft Data Platform solutions and services. You can see on the screen which you can find me. I'm available on social media. I also co-host a podcast together with Guy Glanzer at SQLServerRadio.com in English version or for Hebrew version. What else? I am a micro certifications and such. Yeah, I think that's good enough. So let's get into it. Expenses and money. So what do we spend money on when it comes to SQL Server estates? Most of all, we spend on CPU cores and on network bandwidth. In the vast majority, from the field, this list actually looks more like this in terms of priority, in terms of how much is being spent on each. So licensing is actually usually it is the most expensive component, and then it goes to CPU cores, which also in its own way affects licensing, and then below that RAM, and then network, and then storage at the very bottom. Of course, this can change based on different scenarios, the different estates. Maybe you are in the cloud, maybe you're not, maybe you have your own. But usually, in most cases, this is how it looks. So let's go and dive in on each of these component types, let's say, and see what can be done to reduce the spend and reduce waste of money on them, because there is waste. We see from experience, don't follow these best practices that I'm about to be familiar with it. First of all, let's start with CPUs and memory. You will see that it also affects licensing. Let's start with an hypothetical server. Logical CPU cores. These are logical CPU cores. I'm not going to go yet into the differences. What is a logical? What is a physical CPU core? I'm going to put it aside for now because usually when it comes to money that you're by the logical CPU cores, it is also what affects. Sorry, it also what affects licensing in SQL Server. So let's start with it. First of all, in SQL Server, in the system DMVs, there is no representation for CPU cores. I mean, there is sysinfo DMV of CPU cores on the server, but there is no DMV for like select from sysdm OS CPU cores or something like that, in order to get a record per each cores and per each core and see what's it doing, what is its status. There's nothing like that. But what we do have is something called SOS schedulers or SQL operating system schedulers, and it's basically sort of thread, system thread that is attached, that is logically attached to a physical. And in essence, you can say that it represents a CPU core. And there, to get a list of schedulers, and that is what we would be looking for. So when SQL Server comes up, starts up, it assigns an SOS scheduler per each logical CPU core. Okay. Now let's introduce something that is called NUMA nodes. A NUMA node, or a physical grouping of CPU cores. There's a present physically, like maybe a socket, maybe a physical core with hyperthreading, or whatever else it is. And right now, for this at this phase, at this level, let's just know that a NUMA is a logical or physical grouping of. Beyond that, we also have something that is called a memory node. And each NUMA node is assigned to one memory node. And a memory node can have one or more NUMA nodes. And what a memory node is basically presents like a memory card, or maybe a few memory cards. And those memory cards are specifically to the CPU cores in the NUMA nodes that are assigned to the memory. I'll go into that a bit in a bit more later, but for now, know that a subset of the physical server's memory, and if you have more than one memory node on your SQL Server machine, that means that your memory, the address space, is actually split between these memory nodes. And we'll see just in a bit how that affects how SQL Server works. In this architecture, we have 4 NUMA nodes. Each pair is assigned to a different memory node, but there could also be architectures where we have 2 NUMA nodes, each one assigned to a single memory node, separate memory node. Maybe we only have 1 memory node, and maybe we only have 1 NUMA node, which is same as to say this server is without. There are different types of architecture, different ways to distribute your logical cores across NUMA nodes, and different ways to distribute nodes, and it all depends on the also logical way. Essentially, let's start with this thing exists is so that each logical processor that is assigned to a specific memory node will have direct and fast access to that memory, to the memory space that belongs to that memory node. And actually, most times, I think, it means that these NUMA only their specific memory node. And they either can other memory nodes, for example, NUMA node 0, address space in memory node 1, the one on the right. But in some architecture, it is possible, but there is a like the logical processors on the left could access the memory space on the right, but it will be much accessing their specifically assigned memory node. Okay, so that's what it means to have a NUMA architecture. Why am I telling you all of this? This is not a lesson in system architecture and such. because it has an effect. It has an effect on money. It has an effect on spend. It has an effect on licensing, which also affects your spend, obviously. How? Let's take, for example, that we have all of these three processors on the CPU cores on the right. For some reason, they are not available. They broke down or something. For whatever reason, SQL Server cannot. There are two logical cores in the last NUMA node. Both of them are unavailable. That essentially means that this entire NUMA node is unavailable as a whole. If we have one more processor becomes unavailable in the NUMA node next to it, memory node becomes unavailable to SQL Server. That means that SQL Server is like limping on one. The physical server has this entire memory space. It could be, even terabytes, but in actuality, SQL Server can only use half of it because an entire memory node is unavailable. Why is it not available? Because all of the logical cores assigned to it are unavailable. So, for example, we have, for whatever reason, we have an offline scheduler, which means there is an unused CPU core. With the scheduler or the problem with the physical CPU core, it doesn't matter. But for whatever reason, that CPU core. So let's take, for example, if we open up Task Manager, we would see that these CPU cores, they do either nothing or next to nothing. There is a way to detect that situation by querying from the DMV that I mentioned, sysdm OS schedulers. And over there we have columns where if we filter by whether is online is 0 or the status is visible offline, that will give us a list of all the CPU schedulers whose CPU core is unusable. Now, if we core is unusable and we have a NUMA architecture that splits the memory space between logical core, a problem similar to this, where half of our memory is not usable by SQL Server, even though the SQL max memory setting is high enough. There is a way also to detect that by querying from sysconfigurations to get the max server memory setting, and from sysdm OS sysmemory to get the available physical memory and the total physical memory. And this is on the screen is a simple query to get to detect a situation where at least 40% of the total available memory of the total physical memory, sorry, it is free. That's an under. That means that you are wasting money on your hardware, but SQL Server is not using it. Speaking of the max server memory configuration, that in itself could be a problem. If for whatever reason it is set too low, then obviously that means the SQL Server cannot utilize the RAM memory beyond it. I saw where at some point the max okay, but then at some point the server was scaled up, was upgraded, and they added more memory because they said, you know what, there's a lot of enough memory. Let's just throw money at the problem, add more RAM, and hopefully it didn't because they forgot to change the max server memory. So before, even though the customer was already paying for the added memory. So don't forget to check that as well. There are also considerations or rather scale limitations based on the version or edition of SQL Server which you are licensed. So you can see on the screen a summary of the versions of SQL Server and what were their scale limits for the respective standard web and express editions. In enterprise editions, it is not limited by the express editions. It is limited because of the or express. That could be an important consideration if you have an estate with SQL Server estate with an old version of SQL Server. For example, let's say you have SQL Server 2012 Enterprise Edition. Okay, your licensing component alone. Enterprise Edition is also the expensive. So that is a lot of money. And if, and I, so you would hear me well, if the only reason of the scale limits, then you should consider upgrading to a newer version and downgrading the edition if for the same scale. For example, edition was limited to 64 gigabytes of maximum memory. If you have an enterprise edition, just 8 gigabytes for your SQL Server, that is the reason for you to upgrade the version and downgrade the edition, because you would pay less for the you would actually essentially. Okay, obviously there are different considerations to have enterprise edition, and scale is not the only one. So it's for your consideration. It depends on how critical it is. Your requirements specifically for from your enterprise edition. So it depends on scenario with whether it is only because of scale or because of specific features. It's up to you. But if you fall into the I pay for enterprise just because I want to have a bunch of memory used, then you should take that into consideration. I imagine that with time, newer versions will be released. They will keep updating these limitations for the standard editions. So it's important to stay up to date and keep your be updated about those limitations as new SQL Server versions are released. As far as I know, there is no change in that. As far as I know. So just keep an eye on it. If you have virtualization, consider, as I said, when it comes to licensing, and also when you pay money for logical cores. But as you saw previously, the limit is on physical. It is limited to a lesser of 4 physical sockets or 16 physical cores. So that is important to remember in virtualization, because in virtual physical per se, but you do have something that logically represents something physical. For example, in VMware, you have something that looks like this. You can configure the total number of logical cores, number of virtual sockets, and the number of cores per socket. Socket, I remind you, is something that factors into the limitation, the scale limitations of standard and below editions. An actual use case, like a true story, that where to have 16 cores, 16 logical cores. SQL Server was not able to use all of them. And the reason for that is because they configured too many sockets. They configured something like what did I say? I said 16. I said 24. They had 24 logical cores, okay? And they slapped on 6 virtual sockets with 4 cores per socket. But the number of sockets was too high. So SQL Server was not able to cores. So instead of 24 cores, they had 16 cores that the SQL Server was able to use. All it took is reconfiguration of the VM, just under the number of sockets and the higher number per socket, and the problem was solved immediately. In different vendors, this is an example for VMware, but there are similar configurations and on the cloud, it's like in AWS or whatever. Figure the number of logical cores differently by playing around with the number of sockets and so on. So it's important to be familiar with it. In the error log, the SQL Server error logs, it is possible to see right next to the startup just, you know, but when the instance just starts up, several informative messages, one of which is how many able to use. So that's an easy way to detect whether SQL Server is actually using all of the cores that it can available to it, and if not, then why? Error log, you could have SQL Server detected 24 logical cores with 16 cores due to licensing limitations or something like that. So to summarize what we had thus far, remember to check your Mac server memory configuration. It could, and situation where CPU cores would be unusable could be either to SOS scheduler issues, which is to say at the SQL Server operating system, and maybe you're missing an update. Installation level, or maybe there are unused, which is too low, and then there's the whole mess with the sockets, or maybe, for example, you have 24 cores on your machine, but allows for only 12 or 16, then it doesn't help you that you upgrade your machine. You also need to upgrade your license. Or due to virtualization issues, such as the configuration issue that I just mentioned. There are also possible issues that could be due to the hard NUMA or soft NUMA configuration issues, that is something that you would take up with your sysadmin or whoever is in charge of virtualization or the hardware. Maybe a CPU to fail or whatever. Yeah, okay. And also, oh yeah, that's what I just said. And there could also be, because the problem is with the CPU itself due to hardware issues. That's also possible. And such problems could lead to wasted licensing cost based on CPU cores. It could lead to wasted hardware cost because you're paying for hardware that SQL Server is not able to use. And the same thing for memory. Maybe you're paying for hardware for memory that SQL Server is not able to use. So what steps should we take to resolve? First of all, make sure you have the max server. You can use an Affinity Mask, CPU Affinity Mask, to by default, SQL Server goes and activates or rather assigns the schedulers to each CPU for how they are distributed across NUMA nodes. And if SQL Server is unable to utilize enough CPU cores, that you would have an imbalance. You could have an imbalance in your in the stress across fully utilized, but a different NUMA node has only just a handful of CPU cores assigned. It's a whole memory space that is wasted. But if you evenly distribute the CPU cores manually using the Affinity Mask, that could help, because that will help SQL Server to balance the load across the different. There is a script in our toolbox. We have a toolbox in GitHub. I will show you the links at the end of the slide. With the script that does exactly this. It detects how many CPU cores there are, how many NUMA nodes there are, how many CPU cores are actually active or usable, and then sets an Affinity Mask automatically to evenly distribute those CPU cores. So that could be very useful. However, that should only be a last resort, or rather attempt. The issue was detected, but in order to fix it, you need to, I don't know, place an order for new licensing, or place for a downtime, and either way there would be time until that happens, until that is resolved. So until then, you should have your NUMA nodes, at least as a temporary solution. Of course, once you do take to change it back to set the Affinity Mask. And as I said, the integration settings, make sure they are configured properly so that you don't go over the scale limitations of the license you have, the edition you have. And of course, you could also upgrade your license, for example, in order to match the hardware that you have, or license that you have. Obvious solutions. Okay. Let's talk about storage. Even though it is at the bottom of the list in terms of impact on money, it is still a factor. in states with very, very large disks. So what I'm showing on the screen is was an increase in space utilization of SQL Server. The data was deleted or archived or migrated elsewhere. Maybe it was consolidated. Different files maybe were consolidated. Contract operation, a deployment type thing, where, for example, I know you added a new column and then you needed to do some refactoring, populate it with data, then delete an old column, for example, or an old data table, I mean. And at the end of this deployment, this process, you're left with a bunch of unused space. And also this can happen due to data compression. Maybe you compress a significant portion of your data and you're left with this. An 80% utilization of your disk, but in actuality, only 20% of it is actually in use. 20% of the disk. So it's important to detect this situation, and it is possible using system DMVs, such as on the screen. Note that the file property function is dependent on database context. So you would have a database. In our GitHub toolbox, there is a script that does this for all databases. This one, server hardware utilization, underutilized, sorry. Later at the end of the slide. Yeah, okay, so how do we deal with it, with such a situation? Obviously, you can shrink files. A portion of your file it again. That's a good reason to shrink files. Obviously, you should. And there is a block carefully shrinking files. The short version of it is you should do that incrementally in chunks. And there are also several use cases where a shrink could take your database, and there's a way to detect that and deal with it in advance. Again, I'll show the link later. You should also consider consolidating files. If you have different database files spread across different disks, but each of them utilizes a very low percentage out of the disk, it should be worth to consider to consolidate those files on the same disk, especially in cloud providers, but not only. The cost per increases almost logarithmically. That means that let's say if you have a certain sized disk, if you increase it by a factor of 2, it doesn't necessarily mean that the spend on it will increase by a factor of 2. But if you have 2 separate disks, each of them with the same size, then yes, that would be a factor of 2 in terms of spend. So if you consolidate them, you would save money, right? And performance, because cloud providers normally the performance of tied linearly to their size. So if you increase a disk by a factor of 2, its performance would also increase by a factor of 2, but you would pay less compared to guys split into 2 disks. They will be slower and you will pay more for them. So that's an important consideration. And then you could also resize, if you don't need all of that extra space. You could resize the disk. Of course, that means detaching the disk, moving them around. It's a serious when you do that. Let's go and think about the other direction. What if you have an overutilized storage? So maybe you don't really need to utilize all the storage. Maybe that you don't really need. I saw lots of situations where there are huge tables. They are not actually used because it's very old or it's irrelevant or whatever. Consider having a deletion, apply data compression where possible. If you have a recent enough SQL Server version, you should consider for data that you don't need to access frequently, but the table is very large, like historical tables and so on. Column store and column store archive compression is very, very useful for it. It can be incredible. It can have incredible savings in terms of can save up to 10 times compared to the original size. So it's worth it to consider. And as I said, you could consolidate files into larger disks. As I said earlier, the cost would usually be non-linear, so you would actually save money on that. And everything I said, organization policy. Oh, right, I forgot. In some cases, it will be easier and even cheaper to dealing with deletions and migration and archiving processes and downtimes and all of the human effort that is needed for that. That human effort could cost money and more than it's worth. So, and as I said, storage is usually the cheapest component. And again, organization business policy may vary and it depends on your environment, but it is an important consideration. Now about licensing. Again, as I said earlier, you should have important consideration to have enterprise edition, which is very expensive. If the only reason you have an enterprise SQL Server version and you need partitioning or compression or column store or in-memory OLTP and or something or TDE, then you should consider upgrading the version and downgrading the edition because all of these features are could be available and all you have to do is upgrade the version. Okay, so that is an important consideration. Of course, again, there are different benefits to enterprise edition, so it depends on your specific use cases. More or less on licensing, if you have a software assurance agreement with Microsoft and you have a availability group that is only used for DR, it's only used for failover, and unless it is the primary, it is that fits the category to have a passive HDR instance, and in this case, the licensing for SQL Server is free. So if you have a primary node, just waste your money, then that is a very important consideration to have, and you need to discuss this with whoever is responsible for licensing in your organization and talk it out with your Microsoft representative and so on. More on licensing, specifically in Azure, and in some extent, it is also relevant to AWS and such. Dev test subscriptions. You can have an entire subscriptions that is designated. If you have a license that you already paid for, let's say you migrate from on-prem and you already have a license, and you're using that same license after you migrated into Azure, you could have the hybrid benefit, which entirely removes the licensing component from your SQL Server estate and in Azure. And one more thing, reserved instances is very important. It can have serious savings, very significant savings, up to 72%. If you create a reserved instance, you basically sign a contract or something. It's like saying, you know what, this server that I have, I declare that I will use. Okay, so if you do that, you pay in advance. It's something not necessarily pay in advance, but you monthly, but you reserve the instance in advance, and you can have up to 72% savings. That is true for virtual machines. It is true for certain sized, a whole bunch of Azure services, managed instance, Synapse, all kinds of instances. What happens? Change the size of your resource before that reserved period ends. So if you upscale it, if you increase the size, there is no you would be paying for a reserved instance. You just add a difference. It's not a penalty. What if you do want to like cancel the resource or reduce it, and then you do in a way break the agreement? So what happens is that you have to pay 12% of the what you owe for the reserved instance. Again, 12% of the remainder. That is not a lot at all. We calculated it a while ago. By rough estimate, this means that if you purchase a reserved instance for 3 years and get like around 70%, if you violate the agreement within more or less ballpark estimation, right? 7 months, within 7 months, you already got your money back guarantee, including the 12% fine. Okay? Compared to if you would not have reserved instances, or if you had a reserved instance for just 1 year. Money worth. So what I'm trying to say is there is no reason not to do it if you can. If you have a resource which is eligible for reserve. I think there is a rumor behind this rumor, and I don't promise anything, but even if you break the reserved instance and then you're supposed to pay that 12% fine, Microsoft doesn't necessarily collect. It's more like a recommendation, or like they reserve the right to do. It's a rumor. I don't guarantee anything. It's up to you. But again, even without it, it's worth it. Okay. So go ahead and do it. One important thing about reserved instances: if your Azure subscription is provided via CSP, a cloud solutions provider, I'm afraid you're not able. Is not supported as part of the CSP agreement. But if you don't, then go ahead and do it. Now about network bandwidth. I won't go on too deeply into this because that is very complicated. It is a very complicated topic. I won't go too deeply into it. I would just say in a few words that outside traffic into the Azure network, outside I mean like from your on-prem estates, whatever it is, that is free. You don't pay for that. Outside bandwidth costs money. Traffic between regions and also traffic between availability zones. That costs money. What doesn't cost money is traffic, as I said, from internet, from outside into Azure, and traffic inside the same availability zone. Possible, place as many of your resources into the same availability zone. Unfortunately, in Azure, you can't directly control it, but you can do it by creating something that's called an availability set. An availability set guarantees that all of the resources that were created in this availability set are guaranteed to be within the same availability zone. And then traffic between them will not incur additional costs. In case of AWS, it's very similar. Same type of idea, okay? Same idea of what I just said, and costs, type of costs, pricing also applies there. Right, we are nearing the end. As I promised, /Modera data /Modera toolbox, and then inside there's all kinds of folders and scripts, such as script that I just said. No, that's not the one I said. It's a script to detect an imbalance in terms of performance, and it is utility script, sorry, to automatically balance CPU cores across the one server hardware underutilized. It's a massive script. It checks a whole bunch of different things, and also a very useful script to detect candidate tables and indexes and partitions for compression. I call it the ultimate compression savings, and I strongly recommend using it. It checks your entire database, all of the tables in the database based on a set of parameters. You can control it and customize it, and it outputs the recommendations for you so that you would have, okay, these tables should have a significant savings. Here we should have page compression, there we should have row compression. And it also outputs the remediation script even. You can have it right there. So, and I think that's about it. We're just about finished our time. So if there are any questions now.
I don't see questions.
Everything is clear.
Nothing. Yeah.
That's great.
Hopefully they will save a lot of money.